What's going on, everybody? Gareth here, FCP Euro. Welcome back to another DIY video. Today we're going to be working on an E46 M3. Now, based on the car that's on the lift over there and based on some of the parts that are sitting here on the table, I think it's pretty safe to assume you already know what this is going to be about. But yeah, we are going to be doing rod bearings on the S54. In this car's particular case, it does have a Blackstone analysis, which shows that the previous oil change showed an elevated level of lead and copper, which usually means the rod bearings are on the way out. We do know that the rod bearings on this car were replaced at 30,000 miles under warranty, but as far as we know, they've not been touched since, and now it's somewhere around 184,000 miles. So those rod bearings that were replaced have done about 154,000 miles. And this car has also seen a couple of track days recently. In fact, the last oil change was after a track day, which is why we believe we're seeing those elevated levels. So the car runs great. Other than that, there's no knocking noises or anything else that brings us to be concerned. However, we are going into this in kind of an exploratory manner and making sure the engine is still in overall good condition. And if it's just a matter of replacing the rod bearings, we're going to show you how to do that. But with that said, let's talk about some of the tools we're going to need to do this job, and then we can go ahead and jump right into it. All right, let's talk about the tools. I'm wearing a different shirt. Probably already noticed that. That's because we're talking about this after we finished everything, just because we didn't want to miss anything important. Fact of the matter is, this is a huge job. There's gonna be a large variety of different tools you're gonna need to get this job done successfully. Not included in this is some kind of engine support bar to support the engine for the top once you lower the subframe. You will want something like that. There's obviously different manufacturers of those types of tools out there. We're not gonna specify which one, but you're gonna want that at the very least. I'm not gonna get into the granular specifics about some of the socket sizes and things like that. We have a full list of what we use in this video, but it's traditional sizes like 8, 10, 13, 16, 18 millimeter. You will need an E12 Torx socket for the connecting rod bolt, so that's the one, I guess, specialty size you might see. But past that, some of the other tools you're going to want to have on hand, if you have access to a torque wrench that does torque angle or is programmable for the individual steps for torquing the connecting rod bolts, recommend you have that. But of course, you can use a mechanical angle gauge. That's totally fine as well. Past the torque wrench, you'll need the 32 millimeter wrench and counterhold tool for the fan clutch, which is mounted to the water pump. There's really no other way to get that off, so that is a specialty tool that you need for that. Here's another specialty tool. This is from BMW. This is specifically for rotating the crankshaft. There's 4 bolts on the front of the crank, and this tool is designed to allow you to evenly bar the engine over by hand and not putting undue stress on those smaller E12 bolts that are used to mounting the harmonic balancer. So you will want to have this on hand. It's going to make your life a lot easier. You want plastic gauge. BMW recommends PG1 specifically for this job. It's a quick and dirty way of measuring the bearing tolerance. BMW gives you a specific range within TIS. So this is going to be the easiest way to verify that in fact the new bearings that are going in give you the tolerance that you need to have. It's not the most accurate measurement tool in the world, but for this job on an engine that's already being run, and that tool is going to give you that option to do that quick and dirty. Past that, you'll need your typical assembly lube and silicone. Paper towels, you'll be using a lot of these during this DIY just because of the oil dripping out of the engine. A paint pen, that's what I recommend for marking the connecting rod bolts. And then using some denatured alcohol to clean the new connecting rod bolts before installation. It's best to get all of the assembly lube off of them and make sure that they're clean before you lube them up for installation. But past that, for the specialty tools that I talked about, like the fan clutch wrench set and the tool to bar the engine over and the plastic gauge and everything like that, we sell all those tools on fcpro.com along with the parts that we're installing in this video. So if you have an S54 and you're looking at doing a rod bearing service yourself, we have you covered on that end, so go over to fcpro.com and check it out. We made it easy to find those items for you. And past that, let's go ahead and jump into the video and we'll show you how to get this done. So the first thing we're going to do is I'm going to loosen the oil filter cap and lift our dipstick, and then I'm going to go ahead and raise the car up and drain the oil. That's going to be our first step in this entire operation. So we're going to go ahead and drain the oil first, like I said. We're going to go ahead and remove the little plug here on the reinforcement plate to get to the drain plug on the oil pan. And then it's going to be a 6 millimeter Allen to remove the drain plug. Word to the wise, make sure the Allen is completely seated, because it is possible to strip the Allen on these pretty easily. While the oil is draining, I'm gonna go ahead and remove the forward aerodynamic shield here. It's gonna be pretty much all 8 millimeter screws. We still have oil trickling out of the drain hole on the oil pan. However, we are dropping the oil pan later, so whatever residuals in there is gonna be cleaned out regardless. I'm gonna go ahead and put the drain plug back on for now as the bulk is out, AKA when we go to remove the oil pan later, it's not gonna dump oil all over the place, which is what we're looking to avoid. So I'll just thread that back on for now, and we'll get the residual out later. Next up, we're gonna take a 16mm socket and remove the reinforcement plate for the subframe. That's going to expose a majority of the oil pan. And then we're also going to, from there, move on and remove our ducting for the oil cooler. Last bolt goes without saying, make sure you have a firm grip on the reinforcement plate, otherwise it will crack you in the head and it'll hurt. And there's always debris. In this case, we have 2 track days worth of tire slag caked on the underside of this. So just don't be looking straight up at it. Wear some safety glasses if you're working on your back. I'm also gonna go ahead and remove this rearward aerodynamic piece, splash shield as well. It doesn't necessarily interfere too much with the job, but for filming purposes, we're gonna have it out of the way because we do have some bell housing bolts that have to come out later on. While we're still underneath the car, we can also unbolt the control arm bushings because we're gonna basically drop the subframe later once we have the engine supported from above. And then we also need to remove the steering shaft bolt as well. So I'm gonna go ahead and remove this now. It's just only 8mm nuts, and then we'll move on from there. Next up, we're gonna go ahead and unbolt our control arm bushings from the frame rail. These are also 16mm. Next up, we have this E10 Torx bolt up on the steering shaft that holds the coupler to the steering shaft. We're gonna go ahead and remove that. Reason being is later on, we're gonna lower the subframe and it won't be possible if the steering rack is still connected to the steering shaft. So that's an E10 bolt. And this is part of the kit that we sell. This will be replaced. We're gonna remove the 2 engine mount nuts. They're 16mm. So we have some extra pieces we need to remove up top before we put the engine support bar up top and then lower the subframe. I need to get the fan out of the way in order to gain access to the crank pulley so we can bar it over later once the oil pan is off. So the fan's gonna have to come out, fan trout's gonna have to be loosened up. First, I'm gonna go ahead and remove this piece here just to give myself a little bit extra space. Just has these push rivets, there's 4 of them, using these pliers to loosen it up and get it out of the way. All right, next up, we're gonna knock our fan clutch loose from the water pump impeller shaft. It's a special thin 32mm wrench and counter hold tool. Just remember the fan clutch is reverse threaded. So it is left-hand thread, so it's lefty tighty, righty loosey. And that came very loose very easily, but this is a relatively new fan clutch. Your results may vary depending on how long it's been on there. We're gonna remove a couple items from our fan shroud here, such as our AUC switch. Actually, we'll just disconnect it. We'll leave it on there. We're gonna disconnect our aux fan, just because we are gonna have to move the fan shroud around a little bit when we're pulling it out. So we'll just kind of get this stuff out of the way. And then from here we have a T20, and then we also have a couple of 10mm screws that hold the fan shroud to the radiator. Basically going to unthread our fan clutch and then pull the whole fan shroud out as one piece with the fan. And that's gonna open up a whole bunch of space on the front of the engine. Also, in order to do that, I'm gonna have to pull the intake because one of the 10mm screws that holds the fan shroud of the radiator is actually blocked by the intake. So it's gonna be one extra step to remove that. But we actually have a full video on how to do that as well, so we can go ahead and drop a link for you on that, but it's pretty simple to get this out of the way. So this car has an aftermarket CSF radiator in it, so the screws that hold the shroud to the radiator are a little bit different. The only one that remains the same is this T25 here at the top. The others are 3 10mm screws. And so I'm gonna go ahead and remove those in order to loosen up the fan shroud. And then once the fan shroud is loose, I can then pull the fan out with the fan shroud. So we have 6 13mm screws that hold the cover to the harmonic balancer bolts. We need to remove those bolts in order to crank the engine over once we have the oil pan off. So removing the fan of the fan shroud gave us access to these screws. Otherwise, there's no way you'd be able to gain access to this. And also, there's no way that you can bar the engine over if this cover is still on. You don't want to try to turn the engine by the cover. I think some people have definitely tried to do that before, but it's just a cover. It's not meant to handle that kind of load. So we're actually shortcutting this because I pulled those bolts out. The crank pulley is now loose. Normally you have to take the belt off, which is going to happen anyway. I'm actually just going to pull this off and the belts are going to come with it. So we're just saving a step here. So we have everything done from the top of the engine. We now have access to the harmonic balancer bolts, which we need in order to bar the engine over. We have our engine support brace or engine support bar in place. So now we can go back underneath, start loosening up the subframe, and then from there we'll work on getting the oil pan off. But at this point, we've pretty much done everything we need to do up top. So really the only thing holding everything in place at this point are the 4 subframe bolts, which are 18 millimeters, and then the 4 13 millimeter nuts for the sway bar links. I'm going to remove the sway bar link nuts first. And then we got the 4 18 millimeter bolts for our subframe. We'll take those out now. So before we lower the subframe entirely, I've left 2 bolts in loose. I'm going to go ahead and disconnect our level sensor for the headlight. This is physically attached to the control arm, or also the subframe. So as the subframe lowers, that's going to be fine. However, the thing that will not lower with it is the wiring lead for it. So just disconnect that. We'll depress the lock tab for the connector. Pull the connector off like that. These can be a little bit stubborn because they're usually not disconnected. So, you know, holding the lock tab down and pushing on it with a screwdriver made that easier. Now we're going to go ahead and remove the last 2 subframe bolts all the way. I do have the subframe supported by the center here.
Whoa. Pay no attention to that man behind the curtain.
Just to make sure that as we lower the subframe, it comes down in a controlled manner. I'm gonna lower the subframe here. Just keep an eye on everything. Make sure that it's stable. There we go, the steering shaft fell out, which is what we want to see. Now, we're gonna remove our return line here from the oil pan. It's gonna be a 17 millimeter wrench, and then I'm just using an adjustable plier wrench to remove the fitting. The fitting is a swivel fitting, so it'll spin on its own while you counterhold the fitting on the oil pan. While we're still here in the back, we're gonna remove a couple of bell housing bolts that go through the transmission bell housing into the oil pan. So you have this E10 here and this E10 here as well. We need to remove those, so we'll just do it while we're here. We're gonna disconnect our oil level sensor. And then from here, we have a 10 millimeter nut that holds the dipstick tube to the oil pan. And then I'm just gonna go ahead and pull the dipstick out so we know that it's loose, which it is. And then we also have this connector here for our PCV system. We're gonna go ahead and press the 2 little tabs on that and then push up off the barb. So right here, you need to press those so that it deforms like that, and then it'll slide off this little barb on the oil pan. And then we also have this little plastic tab that holds the wiring lead for the oil level sensor. We'll go ahead and pull that out as well. And then there's another one up here that we'll need to do, since that is also connected to the side of the oil pan. Want to make sure that once we start removing the screws for the oil pan, that something else isn't in the way preventing it from coming down. We have a 13 millimeter bolt right here that bolts the power steering pump support bracket to the side of the pan. Just want to loosen that up. Shouldn't be too tight. I decided to go ahead and remove the other 2 13 millimeter bolts that holds the power steering pump to the bottom of the oil filter housing. Reason being is there's a couple of 2 10 millimeter screws that are obscured by the pump. I could probably get them without the pump being there, but for the sake of the video, I think it makes sense just to get this out of the way. So at this point, we have a bunch of 10 millimeter screws we have to remove in order to get the oil pan out of the way. So we're really just gonna work around the perimeter here and remove them. The ones that are gonna be most difficult are gonna be over this little hump here in the sump, and I have to use a ratchet on those. The rest of it, I'm just gonna use this impact gun. then lastly, we have two 10mm bolts that come up through here. Those are the last ones that we need to get. And just give myself a little extra space by removing this power steering line, the pressure hose. Just not giving me the clearance I need for that forward portion of the sump. So now that we got the oil pan off, we can see the bottom of the engine here. In order to gain access to all of the connecting rods, we need to remove the oil pickup tube. It has two 10mm nuts that support it from the side, and then there's two 4mm Allens at the front of the oil pump that secure the rest of it in place. We're gonna start with the 10mm first. So for the sake of this video, I'm gonna pretty much explain how to check everything and do everything for connecting rod on cylinder number 6. It's the same process all the way down the line, albeit maybe slightly different just because you have to work with the engine and you know, things could be a little bit in the way. But number 6 is the easiest to film, so we're gonna start here. The rod bolts on this engine are gonna be E12s. There are earlier versions of the S54 that would have used a 12 point. And for that, you're supposed to reuse the rod bolts for the later production or any engine that has the updated connecting rods in it. It's gonna be E12 Torx bolts, and those are gonna be one-time use only. So let's go ahead and get into it. Let's see what we're working with here. So one thing to note, S54 connecting rods are fracture split, so they can only go on one way. Basically, the entire connecting rod is formed, and then it's basically split with pressure. So here is our number 6. This is our bottom bearing. We're gonna take a look at that after I get it cleaned up. But next step, we need to push the connecting rod off the journal, and we need to take a look at that upper bearing as well. Here's the number 6 upper bearing. The loaded bearing is always gonna have the most amount of wear because with every single ignition fire, the connecting rod is being pushed down on this. And as you can see, we are through the top layer and into the copper on this. Not the worst wear, but definitely some wear. So we're gonna go ahead and install the new bearings. This is gonna be a test fit on cylinder number 6. We have to do a couple things. Number one, I wanna make sure that the bearing clearances are correct. BMW recommends using a plastic gauge. That's a very simple, cheap way of ensuring that the clearance is where they need to be. So they use plastic gauge PG1. It's the green plastic gauge. That's what we're using today as well. Also, the ACL extra clearance bearings we're using, there is no upper, there is no lower. It is the same bearing on both halves. BMW, if you use genuine bearings, it'll be marked red and blue. One has to go in the upper position, one has to go in the lower position, but the ACLs do not. So with that said, inserting the bearings is fairly straightforward. I will be using assembly lube after doing the plastic gauge check, but what BMW wants us to do with the brand new connecting rod bolts is we basically need to yield them. So it's a 3-step process in which you have a joining torque, a set torque, and then an angle of rotation. On the first pass through is when we use the plastic gauge. After that, we'll then put assembly lube on the bearings, put it back together, and then we'll do the torquing sequence on cylinder number 6, and then that'll be done. So that's how we're gonna do pretty much all of them. At this point, installing the bearing is very simple. You have a little tang. You wanna line up the tang in the connecting rod half here, and then you simply just push the bearing into place and it will self-locate as such. And when you hear about spun bearings, it's always because the bearing has worn down so much that this little tang, this is what retains the bearing in the connecting rod shell. Once this tang is gone, there's nothing holding it in place. The bearing spins. Massive catastrophic engine damage at that point. So this is always something we want to be aware of when we're doing this. So I have the plastic gauge sitting on the lower bearing shell. That is going to be on a completely clean and dry crankshaft. I'm doing cylinder number 6 as a quick check to make sure the tolerance is where we need to be. I've also cleaned the bolts. I used a little bit of denatured alcohol, let them soak, and I've gone ahead and re-lubricated them with some oil. The oil is important to make sure that when you are torquing the bolt down, it actually does achieve torque, particularly on the seat of the bolt against the bottom of the connecting rod. So here we go. This is going to be the test. So on the first step of tightening these factory rod bolts, it's a 12-step procedure in total, but the torquing sequence is 5 Newton meters as a joining torque, 30 Newton meters as a set torque, and then 105 degrees of rotation. Loosen, and then follow that procedure again 2 more times. The whole point is to stretch the bolt. Now, of course, if we had a stretch gauge and we had a stretch spec, that would prevent all that, but this is how BMW wants you to do it with the factory rod bolts. Now we go ahead and take it apart. And right there you can see the plastic gauge is stuck to the crankshaft, and we'll use the gauge that they provided us to do a measurement, and then we're going to compare that against the BMW recommended spec. So the specification from BMW on these plastic gauge should be between 30 thousandth and 70 thousandth of a mil. And we're going to use a little gauge here as a measurement to compare. It's a fairly wide window. But we're somewhere between, we're very close to like 50 thou, which is dead in the middle on the 30 to 70. So this is not 100% 100 dead nuts reliable, accurate, but this is close enough to know on an engine that's already together when you're doing this work that you're where you need to be. So because we're right in the middle of the scale on this, we know that the clearances are good. We can go ahead and proceed to lubricate the bearings and follow through with the rest of the torque specifications for the rod bolts. We're using a little bit of Liqui Moly LM48 installation paste. I'm gonna go ahead and smear it on that upper bearing. I'm also gonna do the same for the bottom bearing. This is pretty much just to make sure that there's lubrication on startup. It'll be washed away pretty much instantly. So again, we're gonna do our joining torque, which is 5 Newton meters. Our setting torque, which is 30 Newton meters. And then the angle of rotation, which is 105. And we have to loosen it one more time. And this is gonna be our last torquing sequence. So I have the special tool from BMW that sits on the snout of the crank here. You can see it has those 4 E-Torx bolts. It would be impossible to really bar this engine over by hand by going on one of those bolts. So BMW has the special adapter that slips over the head of the bolt or the bolts and allows you to basically rotate the engine from a center point, which is a lot easier and more consistent. So this is one of those special tools if you're doing this job, is definitely beneficial. Also, removing the spark plugs from the cylinder head will also make this easier too, but I left them in. All right, so let's just do a quick explanation of the wear pattern on these rod bearings. Over here are the factory connecting rod bolts. They can be torqued up to 5 times, but the installation procedure when you're using new bolts requires that you torque them 3 times, which you would have seen already. It does not really make sense for us to reuse these bolts when we can install new ones, so we remove those from the equation altogether. But here we have the bearings, cylinders 1 through 6, upper and lower. Now, when you look at these, you'll see that the uppers have substantially more wear compared to the lowers. And that is always going to be the way that it is because the upper is the loaded end. Best way to explain it is pistons at top dead center, you have ignition, the connecting rod is being forced down always onto the upper connecting rod bearings. If we look at the lowers, they are all pretty consistent. I mean, there is some wear there, but nothing that is egregious or alarming. Now, when we look at our uppers here, number one, quite a bit of wear. You don't really feel any scoring or gouging, which is always a positive. Number 6 was definitely the worst. You could definitely see some heat spots on that. And if I run my finger across it, I can kind of feel a little bit of gouging, but they're still relatively smooth. Number 2 was also showing a little bit of copper, not nearly as bad as number 1 and number 6. And then 3, 4, and 5 were all pretty much consistent with the same wear pattern. All these engines have different wear patterns. I wouldn't say that, one connecting rod is more susceptible to wear than the other, but considering that we saw the elevated lead and the elevated copper levels in the previous oil sample, and those shot up pretty substantially, that was also after a pretty long track day where it was very hot. That's not unsurprising. It's good that we got in there, replaced them, and yeah, there's no reason why this engine can't go another 150,000 miles potentially. So all the new connecting rod bearings are installed. All the rod caps have been torqued. At this point, I'm gonna go ahead and peel off the old oil pan gasket. We're gonna have to clean the surface of the block before we install the new one. Just make sure that there's no material left over. But we'll just go ahead and knock this out of the way. Did notice a little bit of an oil leak on this engine, particularly on the right side. Pretty standard for an old gasket. It actually looks like a lot of the rubber material is kind of staying behind, which is also common. Stuff kind of gets baked on over time, so we'll go over the whole surface with a razor blade and clean it up. While we're down here, we're going to reinstall our oil pickup tube and also the return tube as well. We put a brand new O-ring on the end of this pickup tube. Very important to do that and lubricate it with oil so it slips into place. It'll just kind of drop in. And then here's our return. And again, these are just 4mm Allens. There's no gasket between the flange and the oil pump. It's a machined surface, so nothing goes in between there. So at this point, we're gonna go ahead and prepare our oil pan to go back into the bottom of the engine. Before we do that, we have a couple of parts we need to install. It's a new strainer for the oil pump pickup. We're also gonna replace our gasket for the oil level sensor. It's not leaking, but no better time to do it now while we're here. And then we'll also slide in our new dipstick tube seal. The strainer is held in with 10mm screws. Now there's a metal gasket that seals this that we need to peel off. This can be a little bit tricky to get your fingers under it, but there we go. And just in case you're wondering what this strainer does, is it helps prevent aeration. We're gonna go ahead and torque all those down here in a minute. Now we'll do the oil level sensor. Same thing, 10mm. And this thing is kind of crusty, so still kind of pliable, but it's definitely pretty firm on the outside there. The old seal is green, the new one is red. Don't know why. I don't think there's any significance behind that color change. Just slide that in. Torque spec on these 10mm screws is going to be 10 Newton meters, M6 thread. And while we're here, we could also do our drain plug gasket, which is with the new oil filter kit. Make sure we put that new crush washer on. And also make sure that the crush washer that was originally there is not stuck to the oil pan. If you double gasket that, it will surely leak. And torque spec on the oil drain plug is 25 Newton meters. Now I'll flip this around, and right there is our O-ring for the dipstick tube. We'll go ahead and replace this now, just with a pick. This is a common source of leaks. And then we'll install our new one right here. Just pretty much slides into place. And the other thing we'll do as well is we'll put a little bit of oil on the inside of that O-ring so that when we put it up underneath the car and put the dipstick tube in it, it'll slide in. The other thing we have to do real quick is clean all this debris off the mating surface of the oil pan. Now go ahead and take a razor blade, just scrape over real quick, take a clean towel with some brake parts cleaner, wipe it down. We'll do the same thing on the engine block, make sure that both mating surfaces are clean, and then we'll go ahead and get the gasket ready to install. The biggest thing here is you could see where the oil pan gasket normally seals. Just want to make sure that any of the gasket material from the original oil pan is removed. So scrape gently. It is aluminum. With a razor blade, you can certainly add some additional surface features, which you don't want. Just sprayed a little bit of brake parts cleaner onto a clean shop towel. Just gave it a quick wipe down. Most of the loose debris come off, and I'm just kind of inspecting this to see if there's anything left over that is like a piece of the old gasket or anything like this. Just also running my hands over, make sure it's smooth. Like right here, I think there's a little bit of stuff. So just want to make sure that the mating surface is clean and that any of the old gasket material is removed. We're also going to do the same thing on the engine block as well. We're going to go ahead and put our new oil pan gasket on. The good news here is it can only go on one way. You can't possibly install it incorrectly. I'm going to go ahead and do a little trick here. I'm going to take a couple of these thin zip ties and I'm going to zip tie the oil pan gasket to the oil pan. That way when we're putting it up into position, it's not going to want to shift around or go anywhere. And then once I have the oil pan in position, I can go ahead and cut those zip ties off. Only 2 of them is really all that's needed. And this way you don't have to worry about trying to line everything once it's up there in position. Also went with the high-vis yellow, that way I can't possibly miss them. So, and then we have that, we can go ahead and slide the oil pan up into position. So we're just doing the same thing here on the bottom of the engine block. I went ahead and scraped it with a blade. For example, this is a piece of the gasket material that came off. That's from the original oil pan gasket, so very important that you clean both surfaces. And the other thing that we're going to have to do as well, before we slide the pan back into place, is you have the front timing cover up here, and then you have your rear main seal cover back here. We're going to go ahead and put a bead of RTV on both of those surfaces because what you have is the engine block, meaning a different surface. And if I run my finger over that, I can basically feel the difference between those surfaces. If you don't put RTV on that, it will not fill that gap, and the gasket is not able to seal that. You'll get a leak through here. So the recommendation is always on these surfaces is to put a dab of RTV. That way when the oil pan goes back on, the RTV will fill in that surface. So we're gonna go ahead and use some Corteco Evo 300. That's our schmoo of the day. And we're gonna go ahead and put a nice little bead here between the timing cover and the engine block. All right, now we're gonna go ahead and slide the oil pan in. I've actually raised the engine up just a little bit from the top to give myself as much room as possible, being very careful with the RTV that we laid down. Because the oil pan is in location, I'm just going to cut those zip ties off. They're not needed anymore. Got a couple of screws in. The key is to leave everything loose. Get all of the screws in by hand, and then once all the screws are in, you can start tightening everything down. The gasket, the oil pan gasket in the rear was a little bit shifted towards the right side, so I just went up there with a Phillips head screwdriver and pushed it towards the left side. And now these bolts are lining up in the rear. It's also important to note that when you're putting these bolts in, not to tighten everything down, you want to get all the bolts started by hand, and then once they're started by hand, I'll then tighten down the bell housing bolts here to pull the oil pan back towards the bell housing of the transmission, and then I can go ahead and tighten down these bolts here to pull the oil pan up to the bottom of the engine block. So we have all of the bolts threaded in. At this point, I'm gonna go ahead and start snugging these bolts down. They're all torqued to 10 Newton meters. I'm gonna be completely honest with you. I'm gonna be tightening these by hand. Majority of these you can't even reach with a torque wrench just because of stuff in the way. Let's leave it this way, 1/4 inch ratchet by hand. You won't be able to over tighten or over torque these things. So just be mindful and try to do it evenly as possible. In this case, you know, the gasket is the thing that does the sealing, not the bolts, so you don't need to absolutely nuke them down. Just use a little bit of common sense and you'll be good. We've gone ahead and tightened all the oil pan bolts down. Like I said, I did it by hand because it's just simply not possible to put a torque wrench on all of these. It's only 10 Newton meters, which is 84 inch-pounds. It's not that much. You're just looking to get them all tight by hand, and that's gonna be perfectly fine. We're using the German recommended torque spec here, which is gluten tight. Yeah. With that said, there's 3 different oil pan bolt sizes. We want to mention that. There's a long bolt, which is going to be here in the back near the bell housing. You have a medium length bolt, which is only going to be used on the portions of the oil pan that have a deeper boss on them. And then you have the shortest bolt, which is going to be like these up here, which pretty much go directly on the oil pan. The thinnest portion of the oil pan is going to take the small bolts. The part of the oil pan that has the thicker boss on is going to take the medium length. And then the 2 long ones are going to be back here, where the oil pan bolts to the bottom of the engine block, but that requires a longer bolt. So we're gonna reinstall the retainer for the dipstick tube. There's a little thing on that says top. That's obviously gonna face up. So we will drop it in place like so. And then we have this little 10mm nut that secures that in place. That's going to compress the O-ring and make sure that it seals so that there's no horrendous leaks coming from the dipstick tube. Now we have our crankcase breather here. That's gonna go ahead and just click into place like so. And then we have our oil level sensor wiring lead. That's gonna slide in there. And then we have this little retaining clip. Bingo. All right, we are done with everything that needs to be reconnected over here. We're gonna go forward and we're gonna reconnect the power steering pump back to the power steering pump bracket and make sure the oil cooler lines are in the correct orientation. We can go ahead and put our power steering pump back up in position on the oil filter housing. The 2 bolts at the top are exactly the same. And again, the key here is to make sure that both bolts are started by hand first, along with the 3rd one off here on the side, before you tighten any single one of them down, because you'll find that aligning them is going to be an absolute nightmare if one of them is tightened. Torque spec on these is all going to be 23 Newton meters. Next, we're going to put our PCV return line, oil return line, back onto this flare. It's a 37-degree flare, basically AN or JIC, but it threads on like so. And the nice thing with these flare fittings is you just need to snug it down. Use a 17mm wrench as a counter hold, and then I have these adjustable plier wrenches to hold on to the fitting on the oil pan so that doesn't rotate while we're tightening it down. We're going to reinstall our crank pulley and the cover. That's how these go together. So this cover here goes over the head of the bolts for the harmonic balancer. And then this is obviously the crank pulley for the AC belt and the main serpentine belt. I'm gonna go ahead and do it from underneath the car since we're still down here, make my life a little bit easier since I can kind of see the holes. And we'll get these started by hand. Torque spec on these, again, 23 Newton meters. Pretty standard spec from BMW for M8 thread bolts. All right, so we're now at the point where we're gonna go ahead and push the subframe back up against the engine mounts and against the body. A couple things to note. You have this like guide here on the subframe that goes up into this dowel hole here on the body. And on the left side, we also need to make sure that the steering shaft slides back into the steering joint. Also made sure that the steering wheel is pointed straight ahead, and you'll be able to get this on the first try. Now you notice on the steering shaft, there's a little notch right here. That needs to line up with the opening at the bottom of the coupler because that is where the bolt for the steering shaft goes in. This should go in fairly easily. And once the steering shaft slides in, you want to make sure that the entire bolt hole is exposed. If there's anything in the way, the bolt will not go through. That also makes sure that that little notch on the steering shaft is lined up correctly. Now we can install our new steering shaft bolt, which is an E10. We'll go ahead and torque that down here in a minute. We're gonna go ahead and get our subframe bolts started by hand. Now, when we're tightening these subframe bolts down, it's important to make sure that the bolts towards the rear are tightened first, because that is what centers the subframe on the chassis. Like I mentioned, those dowels go up into the bosses on the body. You want to make sure that you get that tight first before the fronts. Let's go ahead and thread the engine mount nuts back on for now. And then next up, we're going to go ahead and torque the subframe bolts and then the steering shaft bolt. Torque spec on these subframe bolts is 110 Newton meters. Again, tightening the ones towards the rear first and then tightening the ones in the front. The steering shaft bolt is tightened to 22 Newton meters. Next up, we'll go ahead and get the sway bar back up into position. Torque spec on the engine mount nuts is 45 Newton meters. Next up, we'll put our power steering pressure hose back up onto the bracket. These are just 10 millimeter nuts. Now we're gonna get the control arms mounted back to the frame of the car. That one actually just kind of slid right in place. Sometimes you have to leverage the bushing by twisting it, but you know, these actually seem to want to cooperate, which is nice. Torque spec on these bolts is 59 Newton meters. We're going to reinstall the main serpentine belt first. I always start by getting around the crank pulley first, and then it needs to come around the tensioner like that. Comes around the water pump pulley, and then comes underneath the idler pulley, around the alternator, and then eventually it will go around the power steering pump. However, we do need to take tension off of that pulley. And for that, we're gonna use a T50, and we're gonna rotate clockwise as you're facing the engine. Now this has a hydraulic tensioner on it, so it's gonna have some resistance, and then eventually it'll kind of give. And then I'll go ahead and get it around the power steering pump. Make sure that it's around all the other pulleys, and then let go. And then next we'll install the AC belt. This one's going to be easier because I actually have a Allen wrench in the tensioner, so it is locked in a detention position. Similar situation, want to make sure that it is routed correctly. In this case, it's very simple. It just goes between the two pulleys, and then it goes over the top of the tensioner pulley. And then from there, it's a 16 millimeter socket to release the tension on it, which I'll do from underneath. Next up, we're going to reinstall our fan shroud with our clutch fan. Basically have to slide this down all together as one piece, and then thread the fan clutch onto the water pump pulley. And then we're going to spin the fan clutch so the threads get started. And as you can see, we're spinning this in the opposite direction. This is reverse thread, so it's going to be lefty-tighty instead of righty-tighty. With our counter hold and our thin 32 millimeter wrench, we're just going to go ahead and tighten down the fan clutch nut. There we go. And now we can go ahead and reposition our fan shroud. Just want to make sure this is all lined up. We have 3 10 millimeter nuts, those small ones. Those are specific to the CSF radiator. And then we have this long screw, which is the factory screw, which only comes up here into this corner. So it goes through this boss, and then it like threads into the radiator support. Just plugging in our auxiliary fan connector, as well as our AUC sensor, ozone sensor, whatever you like to call it. It's for the recirculated air. So at this point, all that we really have left is we need to reinstall the intake, change the filter, fill it up with oil, and we should be good to go. All right, we're gonna go ahead and change the oil filter here. I'm gonna get the throttle position sensor out of the way. Then we have a 13mm bolt that holds the cap to the oil filter housing. Now the car's been sitting with the oil pan off for about a day, so there shouldn't really be any residual in the oil filter housing itself. But you never know, you might get surprised. We'll take our new filter, drop it in, just pretty much rests in place. And then we have the O-ring that sits in the cap. We need to remove that. We'll take the new O-ring, put it into the cap like so. Just take a little bit of oil, lubricate it. And then we'll place that on top of the filter like so. There's this washer on this bolt. Sometimes it could be, there it goes. Sometimes it can be a little sticky to remove. Pull that off. Then we'll slide the new washer on, and then we'll reinstall that into the oil filter housing. And we'll go ahead and tighten the bolt down. That O-ring that we installed, that is what seals the cap to the oil filter housing. Doesn't have to be crazy tight. I'll reinstall our TPMS sensor. Now we fill the engine with oil. We're gonna be adding 6 liters of the Liqui Moly 10W60 Synth Oil Race Tech GT1. It's recommended for these engines. We've put oil back in the engine, brand new oil filter. Everything underneath has been buttoned back up with the exception of the reinforcement plate and the splash shields, which are gonna go on after we verify that there's no oil leaks. Would not make any sense to put all that back together until we know that for a fact. But at this point, we're gonna go ahead and give it a start and give it a listen. So we just started the E46 M3. Really a couple things to note. The engine, seeing as this is a used engine, there's still plenty of oil left over inside of it, plus the assembly lube. You know, you could prime the engine if you wanted, but in this particular case, it made oil pressure instantly. I had my lights on the oil pressure light, it turned off immediately, and we had that assembly lube inside the rod bearings when we started it. That's already probably been washed away inside the oil anyway. If it was a fresh build, it would help to prime the engine for sure. In this particular case, a couple things I was listening for. Number one, does the engine sound normal? The answer is yes. Not hearing any kind of awful noises. Everything is good. The engine started like normal. A little bit of a stumble there at first, but that's not to be unexpected after rotating the engine over by hand a bunch of times and having a bunch of things unplugged. So other than that, it was fine. A couple other things to note. Yeah, listening for the engine sounded totally normal. Sounds like an S54, and then of course looking for oil leaks underneath. Everything in the oil pan is dry. There's no oil dripping out of anything that we've touched. So that means that everything is sealed up at the bottom, everything is sealed up at the top. All in all, I would call this one a success. There's gonna be a break-in period, of course, on these new bearings. The recommendation, I would say, is 1,000 miles. Drive the car moderately, different RPM loads. Drive down the highway, drive it in town, up and down the rev limit, but don't redline it. You'll wanna give the bearings a proper time to seat in and be good to go. Do an oil change after 1,000 miles. Send the oil off to get checked for, you know, wear metals, anything like that. See that everything is normal at that point, and then go ahead and drive the car and have fun. At this point, it's just a matter of reinstalling the reinforcement plate and the splash shields under the car, and pretty much good to go. So I'm gonna start with the rearward splash shield, which covers the transmission, and we'll move our way forward. We have 3 other 8mm that sit here in the front, but that needs to go to the reinforcement plate, which we're gonna put on next. So here's our reinforcement plate for the subframe. This triangulates the subframe to hard points on the body. Here's the 3 body nuts for the rear that go to the 3 holes on the splash shield. So it needs to go in this orientation. And I'm just gonna get a couple bolts started by hand here. These are all brand new bolts. They're actually all torque to yield. So it is a good idea to replace them. now that we've gone ahead and tightened down the impact, the torque spec on these is 59 Newton meters plus 90 degrees. So I'm just gonna hit it with the 59 Newton meters first, and then I'll hit it with the torque needle second. And lastly, we have our forward splash shield. We'll let the vehicle owner know that this bracket here is broken, needs to be replaced. Also let them know that there's a couple of body connectors that need to be replaced as well. But all right, and that's how you do rod bearings on an E46 M3, or really any S54 equipped vehicle. Even if it's a swap, it's gonna be the same process. Yeah, it's an involved job, but overall not too bad. I'd say the hardest thing of this entire job, realistically speaking, is getting to the #1 connecting rod with the oil pump still in the engine. If you remove the oil pump, it would be a lot easier to access, but that's also a little bit more work, and we're still able to get to it without doing that. So with that said, everything was successful. We hope you learned a lot in this video. If you have any questions or comments, leave in the comment box below. If you like this video, hit that like button. We have a ton of videos on the way, so hit that subscribe button for more. As always, we'll see you for the next one. Thanks for watching.